Hi. So you're probably realizing that when we talk about binary ionic compounds and metals and nonmetals, like in case 2, the metals are here-ish, and then the nonmetals are in the upper right-hand corner. So let's say that they're here-ish, okay? And that's a pretty small subset of compounds, right? You can't really make a lot of compounds, and you're right. And of course, things can be more complicated as you go through. So in come these polyatomics. The polyatomic ions are groups of atoms that have a charge. You can see as you look at them here or on the back of your periodic table. Each of them groups have a charge, and the charge is listed in the upper right-hand side there. Sometimes they'll just write negative or plus, as in -1 or +1. Sometimes they'll write -3. The charge is -3 or -2. You get the idea. Those are just the charges listed after them. And they each have names in their group of atoms that overall, the group of them, when you add up all the electrons, they might have 1 or 2 or 3 more electrons, or 1 or 2 or 3 less electrons than they should, giving them a charge overall. Okay, so they're called the polyatomic ions. On the back of your periodic table, or the sheet here, we're using 70. There's way more of them, but this is the sheet that I use. They're listed on this page alphabetical by name, and then on the other page alphabetical by formula. It's the same 70 polyatomic ions, just depending on what you're doing, which way is easier to find them. Okay, so these are the polyatomic ions that we'll use in this class. A lot of these words you'd recognize, so like carbonates or cyanide or, no, I can't think of any, sulfite, phosphates, all these things. A lot of these things are in foods, a lot of these things are in compounds that we use for health and beauty stuff too. So how do you use their names? How do you write their names and formulas? Oh my goodness. That's what we're looking at today. And it's very similar to what we learned for case 2. It is still case 2. We're just making it a little more complicated. So the notes for that are here. And please make sure that you copy them down into your notebook, or you're using this notability sheet as well. So when you're doing the notes, or when you're doing, we'll start with naming again. I think it's the easier one. When you're naming polyatomics, you still name the first element, and now it's a little bit even easier. You don't need to give anything in IDE. All you need to do is read the name of the element, or the polyatomic, right off of here. Okay, so you find the name, and then you just literally write it down. So for NaC2H3O2. Now the trick is, this looks more complicated, right? But the reality is, it only ever consists of 2 things. The first thing is that one right there. And then the second thing is this one. It looks complicated, but there's a box. There's a line for that here on the polyatomic ion sheet. Okay, so that's the trick, is to remember, no matter how complicated it looks, it's only ever going to be 2 things put together. So the first one, I think maybe is sodium. And then the second thing is we go look for C2H3O2. So let's go look for, now you wouldn't want to go alphabetical by name because you don't know the name of this thing. So you're going to go to this page where it's alphabetical by formula. And we're looking for C2H3O2, and there it is right here. Okay, and the charge is written there too. You don't need the charge because we're not crisscrossing right now. All you need is the word, which is acetate. And so then you go back up to the top where we were, and you say, oh, this is going to be called sodium acetate. Oopsies. That easy. Name the first one, find the second one on the polyatomic ion list. That's all. That's all you have to do. Okay. As another one, you want to try? Give it a second. Here is one of them. That's terrible, worst. Not my best effort on that 3 there. So pause it, see if you can name that. And we'll still solve it the same way. Okay. It's only ever 2 things. The first thing is calcium. Okay, mentally, you don't have to draw a line, but like mentally, that's what you should be doing. So the first thing is calcium, and so we write down calcium. Now we're looking for the second thing, CO3. There's no box for CO3 in the periodic table, which means we're looking for a polyatomic ion. Again, alphabetical by formula, let's go find CO3, and I found it right here. CO3. Now it has a charge. We don't need the charge for this part. Okay, we just need the name, and the name is carbonate. So then we go back up to the top, and we're going to call this calcium carbonate. Where'd it go? Oh, there it is, calcium. Oh no, why? carbonate. That easy, okay? Name the first one, find the second one on the polyatomic ion list, and then name it. Now, when you're writing the formulas, it's more complicated, okay? Because you're still going to do the same thing we did in terms of like crisscrossing and stuff, but now you have to like deal with a lot more numbers and things, so it can get kind of confusing. The rules are right here. You write the charges. You'll recognize it because it almost always does not end in IDE. Something that ends in IDE is like what you learned the other day, where they're both going to be at the periodic table, okay? But if it's like, for example, this one here, this ends in ATE, and so that's not going to be an IDE. So that's like your clue that you're using something that's off of the polyatomic ion list. There's a couple of exceptions, of course. This whole unit is exceptions, but hydroxide and cyanide, they both end in IDE, and they are on the polyatomic ion list. And you're still going to crisscross, and then when you have more than one thing, you use parentheses, kind of like math. Again, this is the kind of thing that maybe you want to just like try a few. It will really be helpful to you. So let's try strontium thiosulfate. Okay, so strontium, look in the periodic table right here. Strontium is a +2 charge. That's the first thing you do is find strontium, find its charge, write it out. We're still crisscrossing like we learned the other day. So strontium, Sr +2. Now thiosulfate, there is no thiosulfate here on the periodic table, okay? So that's your clue. Also, it doesn't end in IDE. So that's your clue to look here, thiosulfate. Now you're gonna wanna use the alphabetical by name page because you're looking for a name that you can read. So we go look for thiocyanate, or thiosulfate, it's right here. Okay, now we do need the charge, okay, because we're going to be crisscrossing, so that's important. So you can see the charge there for thiosulfate is -2. So it's S2O3, and it's got a -2 charge. Let's go back up top and write it. S2O3 -2 charge. S2O3 -2 charge. Okay, and what happens when they're the same charges, right? We have +2. Why won't you work? We have got +2, and we've got -2. Here and here you can't even, who knows. So +2 and -2, so that means that you're going to just they just get canceled out. And so the formula, why is this happening, is Sr +2, or sorry, the formula is Sr, nobody knows what's going on, this is a disaster. Let's pause and come back. Okay, it looks like no time has passed, but I've actually broke my Apple Pencil in half, bought a new one, got it delivered from Amazon, and here we are. So we're on these polyatomic ions. We did strontium thiosulfate. You showed how you can cancel it out. We're going to look at beryllium phosphate next. And the way that they work, same way as before. You find beryllium on the periodic table. It's right here. All my answers are +2. Oh well. And then phosphate. Now be careful because phosphate is not phosphorus right here. It's different. So phosphate is here on the polyatomic ion list. You can see there's some that look similar, so be careful. Like phosphate is very similar to phosphite. You can see that their words are very close to the same. Phosphate has 4 oxygens. Phosphite has 3. You can see they have the same charges as well. So just be careful of what it is that you're doing when you're doing these, because a lot of them look very similar. Anyway, we want phosphate, which is PO4. It's got a -3 charge. So back up to here, we had beryllium, which is a +2 charge. We had phosphate, PO4, it's a -3 charge. Now something unique happens here. When you crisscross, 3 is going to go there, 2 is going to go there. But you can't just write PO42 because it looks like PO42, right? That's not going to work. So instead what you do is you use parentheses. So you'd have, let's see, BE, and that's going to be a 3. And then parentheses around the PO4, and you have 2 of those, right? So this 2 came down to there, and that's, this 2 is right there, but you don't multiply them. All you do is you say, okay, phosphate is the one thing, PO4 is the one thing, and we have 2 of those things. So the formula, a couple messy there, is BE3, PO4, 2. Don't forget those parentheses. A couple others you want to be careful of, like one would be magnesium hydroxide. When you're doing these parentheses, actually you should just take a second right now, pause it, see if you can get it. And when you look everything up, magnesium is +2. It's right here, magnesium. And then hydroxide, there's no hydroxide on the periodic table, so instead you're looking for hydroxide here on the polyatomic ion list, and you can see hydroxide is right there. It's got a -1 charge. So back up to where we're writing, magnesium +2. Oh, sorry, that should be an O. It's got a -1 charge, and then when you crisscross them, 1 goes there, 2 goes there. Eventually you'll be doing the crisscross in your head. You don't need to write out all the crisscross every time. Now, a finer point here. When you write it this way, that means that you only have 1 oxygen and 2 hydrogens, okay? Because that 2 only applies to the hydrogen. So in a situation like this, you're going to want to actually use parentheses around it because you have 2 OHs. That's what that 2 is there for. So whenever you're using more than 1 of something off of here on the polyatomic ion list, definitely make sure that you are putting parentheses around it when you do so. Okay? One more for the MEMS. Let's do aluminum acetate. Take a second, pause it, see if you can get it, and I'll go ahead and finish it. So aluminum on the periodic table is a little bit tricky. It's not over in this left side. It's actually right here. Aluminum. It's in that +3 column. So aluminum is +3. So you write Al +3. Then acetate is a tricky one because acetate's got a lot of things going for it. There's no acetate here in the periodic table. Instead, you're looking for acetate here. It's the very first one. You can see it's C2H3O2. It's got a -1 charge. So let's go back up there and then we'll crisscross it. C2H3O2 -1 charge. The 3 is going to come down there. The 1 is going to go down there. The 1 you don't write. You don't write the charges. And what you get is AlC2H3O2. And then there are going to be 2 of those. This is not my best effort, so let's fix it really quickly. There we go. C2H3O2. And the 3 crisscross down there, so you're going to have the 3 like that. And you can't, the parentheses are needed because you can't just write O23. That would mean 23 oxygens, and that's not what we're looking for. Okay, there's a couple other ones that you should try on the other sheet, which I will explain on the weekly schedule. But there you go. So now you know for case 2 how to do polyatomic ions. Okay, it's been fun. It only took me like 4 days to make. So, okay, bye.